A particle is moving along the x-axis according to the position function. S of t is equal to 3t squared minus t cubed. What is its maximum velocity? As soon as you see the word maximum, you should be thinking that this is some type of optimization problem. And the function we want to maximize is not the function that's given to you, s of t, but the function we want to maximize is the velocity. And the velocity, v of t, is obtained by taking the derivative of the position function. So that's equal to s prime of t, 6t minus 3t squared. I want to maximize v of t. How do you find the maximum of a function? You take its derivative, set it equal to 0 to find the critical point. So v prime of t is equal to 6 minus 6t. Set that equal to 0. 6 minus 6t equals 0. We get t is equal to 1. And that's our critical point. Now, does that critical point actually represent a maximum? How can we test that? The easiest way to test that is to use the second derivative test. So remember, the function that we're really interested in is this v of t function right here. So we want to take the second derivative of that function. So we need v double prime of t, which is equal to negative 6. That is always negative. Since that second derivative is negative, we know that v of t is always concave down. So v of t must have, if it's concave down, then at its critical point it must have a max at its critical point. But the question didn't ask where does it have or when does it have. In this case, t represents a when. The question didn't ask when is the velocity at its maximum. The question asked what is the maximum velocity. So now we have to find out what is v of 1, because that's the critical point. We plug the critical point back into the original velocity function, and we get 6 times 1 minus 3 times 1, which is 3. So maximum velocity is 3. There are no units here, but this would be, let's say, feet per second, centimeters per second, miles per hour, whatever units of velocity they would have given us in the problem had they given us units of velocity.